We are at the dawn of a new scientific renaissance, and now more than ever it is important to ensure that we have the next generation of scientists and engineers to carry on with research and continue building better and safer environments for us to live in. The scientists and engineers of the future are the GCSE students of today. But there is a problem with the way that GCSE sciences are taught. So my question is, how can the teaching of GCSE biology, chemistry and physics be improved to make lessons more interesting and improve engagement between students and teachers? Hello, my name is Elizabeth O'Shea. I am an A-level science student. I am one of the country's youngest STEM ambassadors and the co-founder of Science Rocks, a multimedia platform designed to help GCSE science pupils revise for their exams. Science Rocks started 4 years ago as a Facebook page designed to showcase some simple homemade science films. In 2014, my sister and I presented our project at the Big Bang Science Fair and won the South East England Young Scientist of the Year award, along with several other awards for innovation and creative use of technology. Since then, we competed in the national finals and have gone on to present our work at various national events, such as BET 2016, the International Conference on Science Education at Secondary Schools, and at the launch of the first Outbox Incubator, where we presented our research to Her Royal Highness Princess Anne, the President of the Women in Science and Engineering. As a keen science student, I have always looked outside the classroom to broaden my education, and as the co-founder of Science Rocks, I have had some amazing opportunities to meet with people at the forefront of making science education more interesting. People like Anne-Marie Immerfidden, OBE, the founder of the STEMettes and one of the leading forces in getting more girls interested in maths and computing. Professor Tom Welton, OBE, Dean of Natural Sciences at Imperial College London and the world's first Professor of Sustainable Chemistry. Dr. Andrew Hansen, Chartered Engineer and Head of Outreach at the National Physical Laboratory. Dr. Michael de Podesta, MBE, a Chartered Physicist at the National Physical Laboratory and lead STEM Ambassador for Protons for Breakfast. And Tom Warrender, the brains behind Medical Mavericks, an organisation that carries out school visits to encourage pupils to consider medicine as a future career. We will be hearing from all of these people and many others in the course of this film. It is because of my involvement in promoting science learning outside the classroom that I have chosen this topic for my EPQ. In 1880, Parliament passed the Elementary Education Act, making schooling mandatory for children under the age of 10. Pupils would sit at their desk and learn facts by rote or parrot fashion. And we have come a long way since then. As technology improves, it opens up a wide variety of new teaching methods. Now, instead of just looking at pictures or reading about a process in a book, we could take a virtual tour to watch cells divide and see the structure of atoms with electrons whizzing around us. So, with access to all of these new technologies, how do we use them to teach the scientists and engineers of the future? Firstly, we need to look at current teaching methods. Let's look at how science is taught at GCSE at the present time. The majority of teaching is done through textbooks, supplemented by handouts and other paper-based fact sheets. Some teaching is done through practicals, but the limited number of practicals are scripted to perfection, and the pupils are told the outcome to expect before the experiment has been completed. In other words, there is no discovery, no anticipation, and no excitement. Alternatively, the practical is carried out in the form of a demonstration by the teacher, and the pupils lose out on the opportunity for developing valuable practical skills. Teaching also relies a lot on dictation. This has the advantage of making sure that each pupil has a complete set of notes, which can be used for revision for tests. But pupil engagement is limited to note-taking rather than interaction. Dictation simply allows the teacher to pass on information or facts without ensuring any understanding. Unfortunately, these traditional teaching methods do not encourage engagement or interest in science, and this may be one of the reasons why there is a noticeable drop in A-level science pupil numbers. The Sutton Trust has compiled a huge amount of data looking at issues such as educational success being linked to socio-economic status, and also looking at the conversion rates from GCSE to A-level, particularly in maths and science. One glaringly obvious fact is that pupils who take triple science at GCSE are more likely to study sciences at A-level and go on to do science-based degrees. However, where pupils take double science, the likelihood of taking A-level science is greatly reduced. This causes two problems. Firstly, there is a massive range of career opportunities which require a strong science education and a science degree, e.g. doctors, pilots, geologists and engineers. Secondly, we actually have a national shortage of STEM qualified job applicants, and the problem will get worse over the next 10 years unless science engagement is improved at GCSE level. As an example, in the southeast of England, 30% of the region's businesses are engineering related, and engineering accounts for 34% of the southeast's turnover. There is an estimated shortfall of 30,000 engineers per year between now and 2024. If we compare this to the number of pupils in each GCSE year group, i.e. just over 100,000 in the southeast region, you can see that in order to fill the skills gap, 30% would have to become engineers. This is a high percentage, but I believe it is also achievable if engagement in STEM subjects is improved. Incidentally, the latest research carried out by Engineering UK and published in 2017 implies that for every engineering job that is filled, 1.74 new jobs are created in other fields. So, increasing STEM engagement at GCSE level is actually vital for the economy, but none of this will be possible until we resolve the issue of specialist teacher shortages, especially in maths and physics. Scientists require practical skills, so the curriculum and timetable should allow sufficient time to learn and develop these skills, but there are additional benefits. Carrying out practicals allows pupils the opportunity to think about what they are doing. It allows them to start formulating questions and finding answers, and this is at the very heart of science. Let's take a moment to hear from Anne-Marie Immerfidden, co-founder of the STEMettes and one of the leading players in encouraging more pupils, specifically girls, to get engaged in STEM.
So what we do, our ethos for all of it is it's always free for the girls, it's always fun for them, and there's always food for them. And what we do is we set up, we run experiences, we run events, we set up spaces where girls can come along, where they'll be with the majority of girls, but they are exposed to STEM, the STEM industry, different things that they can make, that they can create, and different people that they may not have met before, and mostly women actually that work in STEM. So we run hackathons where they get to come along and make things and get coding. We run panel events where you get to come and actually meet with people and network in a way, but just get to, have you ever met a female engineer? Have you ever met a female technologist? Have you ever met a male technologist? That kind of thing. So they get to meet people, but also where they get to see the companies. So we do things like school trips and all sorts of, lots of different things, but everything is free, it's always fun, and there's always food.
Obviously, GCSE pupils are not expected to solve science's latest problems, but these investigative skills, both mental and physical, need to be developed from an early stage. The other main advantage of practical work is that pupils are more likely to retain information if they have physically carried out a task. A good example is learning about electrical circuits by actually making them. demonstrations are not as effective as practicals. Teachers will carry out demonstrations, for example a dissection of the heart. Pupils will see firsthand what the heart looks like, how the chambers and the valves are placed, and this is preferable to just studying a picture or reading a description. There will even be a heightened degree of engagement because this is a demonstration rather than a textbook-based learning exercise, but it is not as memorable or engaging as having the opportunity to carry out your own dissection. Scientists use models to understand and explain scientific concepts. Models can also be used to help pupils understand more about the topics they are learning. Organic chemistry is a great example where models can be used to help understand concepts of bonding and molecular shapes. Molymod help pupils to build organic molecules and also help them understand what's going on in a reaction. As an example, ethene reacts with steam in an energy-intensive and high-pressure reaction to make ethanol. There are other ways of making alcohol, such as the fermentation process, but the first process produces extremely high level of purity. Here is a molecule of ethene, and here is a molecule of steam. This is how the atoms are rearranged to produce ethanol. Here we have ethanol, C2H5OH. Molymods help you understand more about the reaction process than you can learn from just reading an equation in the textbook. Molymods can also be used to help demonstrate concepts such as isomerism, and when it comes to biology, molymods can even be used to make DNA. And once you've made a model of DNA, you can understand a lot more about how it works and how genetic information can be passed on. But there are other models that can be made using household items. One great model that GCSE pupils love making is a model of the digestive system using items found in any kitchen. Science is not two-dimensional, especially when it comes to biology. Making models helps teach the spatial relationships between various elements, and this is the start of a journey which could lead to a successful career as a surgeon or engineer. Presentations can take the form of posters or videos or live presentations and can either be completed at school in small teams or as individual assignments at home. These days, virtually everybody has a mobile phone or video camera, so making short video presentations is easily accomplished. The same applies to laptops and home printers, so it is possible for A4 posters to be prepared using simple programs such as PowerPoint. This style of task allows pupils to be creative and make something they can be proud of. It also helps develop vital communication skills and encourages pupils to think about the type of information that should be presented. Presentation skills are fundamental in the commercial world. Gaining funding for a research project or actually selling the innovative solution you have just created is going to be dependent on getting your point across to a professional audience. As the co-founder of Science Rocks, I have created a range of posters for science competitions, and I have made over 120 short videos on a range of scientific concepts. Making videos requires thinking about a combination of content, location, background, music, graphics, etc. to produce a piece of living communication which can convey so much more than just a poster. I have even found that making videos has helped me in understanding a concept or actually revising for tests because I have had to think about the content and the way the facts are communicated as part of the process. Again, making video presentations is a great professional skill as it is not always possible to speak with the target audience on a face-to-face basis. Very few people actually use the internet as a massive library full of amazing resources. When I helped launch Science Rocks, my intention was to provide a series of short science films between 3 to 5 minutes long that would help pupils understand concepts and help them get excited about science. I am a creator of scientific content, but I also use the internet as a reference source. I have used it to join organisations such as the Royal Institute. I access study aids, filmed lectures, revision materials and additional learning materials from sites run by the Royal Society of Chemistry and the Biology Society. The science departments of a number of universities have some brilliant GCSE Science revision aids. And of course, there are some brilliant films using CGI and animation to explain scientific concepts in a way that cannot be achieved in textbooks. NanoSymbox is an exciting new company that is using virtual reality to create educational content that will show students what atoms and molecules look like. No longer will we have to look at a line drawing or down a microscope to look at flat images. Future GCSE pupils will be able to put their goggles on and actually travel through cells whilst they are undergoing mitosis, and they will be able to observe reactions taking place at a molecular level. The other great benefit of the internet is the use of alerts. Whenever anything new is provided by my favourite science websites, I am immediately notified. In this way, I am kept up to date with a huge variety of resources that will help inspire me and make my learning more engaging. Most GCSE pupils are very unaware of the extent of what is on offer, and as a result, they are missing out on great opportunities. Various scientific institutes produce a fantastic range of periodicals, monthly magazines and specialist texts, all aimed at GCSE Science. These documents often help to bring the subject matter to life and help demonstrate the real-life relevance of what is being taught in the classroom. They tend to be written in a different style to textbooks and can add variety to the reading material available. One fantastic periodical is the Young Scientist Journal, which provides a great insight into the topics covered in the syllabus, but with one difference: it is written by GCSE and A-level pupils. The advent of satellite TV channels now means that there are far more opportunities to watch science programmes, ranging from long-running Royal Institution Christmas lectures through to new documentaries on space, nature and engineering. And in October 2017, Sir David Attenborough launched his new series, Blue Planet 2, and announced that he is looking forward to working on Blue Planet 3. All of this additional wider reading material helps bring the syllabus to life and helps pupils understand the link between the classroom and the real world. Science is focused on solving real-world problems. Professor Tom Welton is Dean of the Faculty of Natural Sciences at Imperial College and the world's first Professor of Sustainable Chemistry. Let's hear what he has to say about the importance of chemistry in dealing with one of the world's biggest problems.
So sustainability in general is important because we need to find a way of living on this planet where we meet our needs, we have the lifestyles that we want, but without wrecking the planet in the process. And that's all that sustainability is about. It's about trying to achieve those two things. But I suppose it should say, even, and then there's a third thing, of course, being able to do that at a price that we can all afford. So we need to be able to do that as well. So that's important. Biofuels is one avenue of research that could help with this. So we know that we have, well, growing CO2 in the atmosphere, we have the Paris Agreement to try and reduce our CO2 emissions. Biofuels can help towards that to some extent because although obviously when you burn it you're still producing the CO2, when you grow it you're absorbing the CO2 from the air, and so you have much less CO2 production overall for the number of miles your car travels. And that's really how you should think about it. It's very easy to get caught up in all sorts of different ways of counting it, but really what you want to know is how far can I move my object that I want to move, my car with me in it, and how much CO2 does that produce? And then biofuels look quite good. They also look quite good in the sense that petroleum sources are getting more and more and more difficult to access. So either because of political problems or because of the geography of where we're getting them from. And so deep undersea wells, the potential of drilling in the Arctic or Antarctic, it's starting to get, well, really, we don't want to be doing this if we can possibly avoid it. And biofuels, because it's fuel from wood, give you the opportunity to use different sources and therefore not have to access those sources.
It's great to get out of the classroom, but with a packed schedule and a large syllabus to cover, it is not always possible. But when it is, there is a fantastic range of opportunities. The traditional answer is always going to be a museum visit. The environment is controlled and it is relatively easy to target a relevant exhibition linked to the syllabus. We have a great range of museums in London, but that does not mean other cities are left without. Over the last few years I have visited the Horniman Museum with its Victorian-style exhibits and a fantastic display explaining classification of the animal kingdom, the Museum of Manchester, the Science Museum, Intech and Aberdeen Science Centre, which are fantastic for encouraging younger pupils to get interested in science, and at Bristol, a brilliant mix of natural history, engineering and a planetarium. And most recently, the Natural History Museum, where I had a guided tour of the tank room in the Darwin Centre. This was an amazing insight into the ongoing scientific research carried out at museums throughout the country. I even got to see some of the original specimens collected by Darwin when he travelled around the world on the Beagle. The National Science and Engineering Fairs are massive events at various locations around the UK. These give pupils an opportunity to meet with STEM-based industries and see how science is once again linked to real-life problem solving. These events are inspiring and very exciting, and they also provide an opportunity for GCSE pupils to present their own projects as part of a national competition. And on top of this, there are some fantastic lectures and study days hosted by universities and aimed at GCSE pupils. I still remember attending my first maths lecture in a university lecture theatre. I was amazed when the lecturer jumped on the desk and started jumping around to explain random number generation. The style may have been unconventional, but it was memorable and that was the point. Different styles of teaching and interaction can help boost engagement and help pupils to become interested in science and gain a better understanding. Once this is done, facts and principles are so much easier to learn, and the pupil is more likely to develop a lifelong passion for learning, which will hopefully take them through to A-level, STEM degree courses and postgraduate study, and that's the point. Without the flow through to universities or STEM apprenticeships, we will not convert today's GCSE pupils to the scientists and engineers we will desperately need in the future. STEM ambassadors are volunteers who visit schools to engage with pupils and bring science to life. I became the youngest STEM ambassador in the UK on my 17th birthday. I regularly visit schools with Science Rocks and put on shows for pupils in Year 5 and 6. I also get asked to speak at events such as BET and March, where I spoke to an international audience of teachers on the creative use of media in teaching science. STEM ambassadors are not just aimed at junior schools. Tom is the owner of Medical Mavericks, an organisation which goes into senior schools to give pupils the chance to carry out some basic simulated medical procedures. Pupils can listen to their heartbeats, get a picture of their own retinal scan and use an ultrasound machine. Pupils can even use a kit that simulates some very basic keyhole surgery. Tom is looking to inspire the next generation of pupils to become doctors and surgeons. Let's hear what he has to say.
We know it only takes one spark, one moment in a student's life that will affect the rest of their lives. We provide that spark.
In the last 4 years, I have attended some amazing lectures and events provided by STEM ambassadors, but my best experience was attending the Protons for Breakfast, a series of 6 events hosted by Dr. Michael de Podesta at the National Physical Laboratory. The events are run several times each year and are always fully booked. The first 3 evenings are lecture-based, a mixture of PowerPoint presentations, live demonstrations and interactive Q&A sessions, with a short half-time break to try out some of the experiments firsthand. The last 3 sessions include breakout groups, where there is an opportunity to discuss ideas in physics and speak with physicists and engineers from industry. It was a fantastic link between the GCSE syllabus and real-world applications and problem-solving using physics. It's hard to believe that in the UK, despite making hardly any use of these fantastic additional resources, we are still light years ahead of secondary teaching in many European countries. In fact, one of the objectives of the British Science Association is to work with government departments to encourage more EU countries to follow the UK style of teaching. Following my presentation at the BSA conference in November 2016, I had the opportunity to speak with teachers from countries including Portugal, Greece and Latvia. I was surprised to find out that science teaching is still predominantly classroom-based, and there are virtually no links between secondary schools and universities, especially in Greece, where new students arrive as undergraduates not knowing what to expect in teaching methods at university. Before finishing my review of some of the ways in which pupil-teacher engagement can be improved, I just want to mention Dr. Andrew Hansen from the National Physical Laboratory. He is the head of outreach at the NPL and a brilliant, enthusiastic presenter. I have seen him perform live demonstrations and lectures on colour and his favourite topic, heat and energy. He also was the headline speaker at the first annual Science Rocks lecture, which I hosted over 3 years ago. And it is Andrew Hansen who introduced me to the expression edutainment. This is basically a style of teaching or passing on knowledge in an exciting and entertaining way. After watching one of his demonstrations, you cannot help but get excited about science. And that is the point I want to make. If we are to improve engagement amongst GCSE pupils who are typically 13 to 16 years old, we have to present knowledge and encourage a desire to learn in a way that appeals to teenagers. And possibly, somewhere along the way, lessons need to be entertaining if they are to achieve their objective. I've already mentioned that the skills gap will be difficult to fill without sufficient specialist science teachers, especially in maths and physics. These specialist teachers need to be passionate about their subject if they are to pass on their enthusiasm and get their pupils on board. They also need to be able to constantly link the syllabus with real-life applications that teenage pupils can understand. There are, of course, other limitations. Time, money, resources, and unfortunately, there will always be pupils who just don't want to learn. Health and safety has an impact, especially in practical lessons, where pupils might be required to use fragile glass apparatus, Bunsen burners, scalpels, expensive equipment, and biohazardous material. Class size is vitally important. Even a proficient teacher may have trouble dealing with a practical class where the class size is so large that even lab space becomes an issue. The internet has problems because the quality of content is not policed. As we all know, we should never trust anything we read on Wikipedia, but there are some people out there who will post content without thorough fact-checking. And there are sites like the Khan Academy, which is populated by presenters who simply love the sound of their own voices and have limited presentation skills. The content is neither engaging or inspiring, and it is so easy to just turn it off. Pupils need to be taught to evaluate information and cross-refer with other sources to ensure that they have correct information. In short, pupils need to have access to a wide variety of learning resources, but with access to the internet, they need to be taught how to evaluate quality and suitability. I will assume that for the present time, the preferred test of knowledge is to have end-of-course exams like the current GCSEs. As long as this remains the case, teachers will be under pressure to pass on information in a timely manner with the primary purpose of gaining a good grade in the exam. Success in GCSE exams can simply be down to regurgitating facts. This does not necessarily imply any understanding. If we remove the need for exams, we could look at more creative ways of learning. Coursework could be assessed, and the individual pupil's notes could be assessed, almost like a junior thesis. Imagine a pupil who has written their own electronic notes. They can now easily be reviewed and edited and added to. Diagrams can be cut and pasted in. Links to additional reading, videos, lectures, etc. can also be added. With regard to practicals, pupils could include their own photos and PDFs of hand-drawn diagrams. The coursework could be easily accessed via an iPad or computer at home or at school. Plagiarism would not be an issue, as there are now programs that can detect when teenagers' notes start to look like they have been written by a professional academic. Teachers could easily mark the work at the end of each topic. The teacher could carry out an interview with the pupil to assess understanding and discuss the coursework, and there could still be a short test. The teacher would ensure that the syllabus is covered during lessons and that appropriate links are made to solving real-world problems. In effect, the electronic notes will be a long-term project that could run alongside posters, videos, and model making. So, what would the pupil gain? The primary benefit would be an increased knowledge due to increased engagement, a wider range of IT skills, experience in presenting work in a creative way, a foundation that can be built upon for those pupils who wish to take STEM subjects at A-level and beyond. In other words, a living document which can form the foundation for a future academic science-based career. Our future economy is dependent on STEM careers. Great Britain is a global leader in science, technology and engineering. We are a major player, for the size of our country, in space technology. But we are nowhere near fulfilling our potential. In fact, there is a danger of slipping backwards if we do not change the way STEM subjects are taught. Many of the resources I have discussed, such as the internet, university lectures, and the use of STEM ambassadors, are all free. There is nothing to stop schools and teachers from immediately taking advantage, and even as a pupil, there is nothing to stop you signing up for university lectures, institute open days, and using the internet for research. Change has to take place to meet the skills gap which is on our doorstep. Thank you for listening, and thank you to the many contributors who provided interviews for this project and inspiration for my own STEM journey. I would just like to leave you with this short film showing you just how amazing science fairs can be. This is Science Rocks at the Big Bang Science Fair, the place to be if you're interested in science.
Okay, my name's Richard Guest, I'm from the University of Kent. We're here with the Identity Detectives. We're looking at various things to do with identity. It's been absolutely fantastic over the last 2 or 3 days. We've had thousands and thousands of very enthusiastic young children coming around, wanting to engage with us, talk about careers in science and what we're actually doing in research. So it's been absolutely fantastic.